No, you're watching me. I'm doing it. You could, yeah. All right. So this is a recording of all the tests. Uh, as much as I'll do today and tomorrow, and then if we don't finish, I'm going to take care of it myself. Make sure to post this as it goes on. So the first test that you had this semester was chapter two on the pre-calc book. Yeah, if you remember, it was like a change when it's like, oh, now we're in the pre-calc section. So with that in mind, let's go through this. First off, we're going to talk about transformations. Generically, transformations are look like this. Y equals A, the F of whatever you're doing, X minus H plus K. This is recorded, so please don't say anything that will cancel your futures. So, A, affect whether it would be facing upwards or downwards, when it's positive or negative. It also affects a vertical stretch. So if it's bigger than one, it will be stretched. If it's bigger than one, and it'll be a vertical shrink if it was less than one. Yeah, there would be an open-ended question that probably has something like this where you would write it, but in multiple choice, it's already written for you. Yeah, you don't need to know that for that section. Yeah. Yes. And reminder, you do have a calculator throughout the whole test. And even though we didn't have calculator necessarily in when we took the test individually, so I'm going to show you how to use the calculator to make your life easier. Okay? Not necessarily. It's just harder because you're doing it all at once. That's really where the difficulty comes from. That's where the difficulty comes from. I would say per question is equal or less. All right. So this one, the A value is -4. Since A is -4, it tells me two things. That means it's going to be vertically flipped. So it's like upside down. And it's a vertical stretch of 4. So that means it's like 4 times longer than it would be compared to the x squared. This plus 6, that's the h value. H value is horizontal movement, so or horizontal shifts. In this case, it's negative h. So in this case, h is -6. You got to remember it's negative, so you flip the h, which means I'll be going left 6 when compared to x squared. And then the k value, which is the last one over here, k value is your vertical shifts. So up and down. So it's +3, you don't flip it. So it's going up, it's +3. So you're going up 3. So this would be the transformations compared to x squared. In a multiple choice, I would list all of these. A fake answer in the multiple choice would list not all of them. So the correct answer is all of them that are listed. I know for a fact one of my fake answers probably going to say right 6 instead of left 6, or flip down 3 instead of up 3, or something like that. Uh, this is +6. So you have to flip the sign to make h -6. And then from there, I know I'm going left. Because in the generic equation, yes. Yeah, yeah, yeah. So you have to think of it, it's like negative. It's technically -6. Yes. Because it would be technically minus +6. Yes, in that case, yes. So that's why I like to identify what h is first and then look at it like that. All right. Next one. For the following function, find the vertex, y-intercept, and sketch the graph. To find the vertex in quadratic form, you could use -b over 2x, or 2a, my bad. Or you could change it to vertex form by using complete the square. That's a lot of work. I wouldn't do that. So your a value, for a quadratic, y equals ax squared plus bx plus c. So a is going to be 1, b is going to be 2, c is going to be -3. So I'm going to plug this in. Negative b, or -2 over 2 times 1. So -2 over 2, -1. So that's the x of my vertex. That gets me the x of the vertex. I take the x, -1, and plug it into my formula. Negative b over 2a gets you that. You remember we called it the axis of symmetry in the vertex, which is just the x of the vertex, basically. So negative b over 2a. So then I go to negative 1, and then I'm going to plug in negative 1 into the equation. Negative 1 squared plus 2 times negative 1 minus 3. 1 minus 2 minus 3. That'd be negative 4. So my vertex is negative 1, comma, negative 4. My y-intercept, very easily, is the c value, or when you plug in 0. So it's 0, comma, negative 3. Sketch the graph. Usually you would make a table with x and y's. I would recommend putting the vertex in the middle. So I know the vertex is negative 1, 4. Yeah. It's 0, comma, blank, yes. And then I would fill out this 0 and positive 1. And over here, negative 2, negative 3. And then fill out these y values by plugging them in. So negative 3, negative 3, 0, 0. Oh, you do? Zeros? Oh, that's a good question. I didn't realize. I must have a different version. My fault. No, no, no. If you're saying zeros, which are the same as roots, which are the same as solutions, which is the same as x-intercepts. So that's when you look at the y and where zeros are at the y's. Yes. That will get you the y-intercept if I plug in zeros for my x's. Oh, then yeah, you could do it like that. Then you have to factor and stuff. So okay, yeah, that's fine. Oh, this is a chart from negative plus. Okay, let's talk about it from the top. I put the middle, the vertex that I found earlier. Okay. Then I plugged in the x values around negative 1. So I just went up 2 and down 2. Then what I would do is take these x values and plug it into my formula. Now, I did this all by hand, but you could also just do it by calculator. You did it on hand on the test, but now you have the opportunity to use the calculator. On the calculator, what I could do is go to y equals and plug in an equation as is. I could go to y equals and plug in an equation as is. As this calculator thing loads.
So for this problem, we could have used a calculator and gotten all this.
Yeah, you just have to know how to look for it, but otherwise, yes. So I'm going to go to y equals because it won't explicitly tell you what the vertex is, so you need to know what to look for. It was x squared. Is it minus or plus? Plus 2x. Thank you. Minus 3. If I click graph, it'll give me the graph. Cool. But what's even better, if I click second graph, it'll give me the table of values. So in the table of values, it's very easy. I can see where my x-intercepts are, or my roots, or my zeros, or whatever. I can see where my y-intercept, because that's when x equals 0. I can figure out what my vertex is. To see where your vertex is, you should be looking at, let me just use the mouse here so it records actually. You should be looking at where it starts to mirror. You can see at negative 1 comma negative 4, above it and below it, the answers mirror. That will be the indication that you're looking at the vertex. That negative 1 comma negative 4 is where your mirror is where your axis of symmetry is, aka is where your vertex
So
is.
when do you do second graph? That's just
Wait a second, I'm going to go to Melanie because she has her hand up. Sorry. Simple numbers like this. Numbers that are doable. Take a note for it.
when you do second graph, you get the graph whatever is in graph one.
If I click just graph, I'll get the graph. And I click second graph, I'll get the table. Yes. So I plug in the y equals here. Technically, you could put multiple, but we don't. You'll see that in the system equations if we get there. All right. Next one, number 3. What's up? Oh yeah. So I mean, okay. So graphing, you just take the points from your table. I have it here, but we just got it from the calculator. Positive 1 comma 0, 0 comma negative 3, negative 1 comma negative 4, negative 2 comma negative 3, negative 3 comma 0. Make your parabola like that. Okay. All right. Number 3, we're gonna yeah, and just make your U shape. And again, you have a calculator on this test, so you could just always click graph and confirm. Oh, it looks like my vertex is in like that third quadrant. Yeah, it drew it. It's in the third quadrant. It kind of matches, okay? It won't give you the direct points, but that's why you click second table. Because I know you just walked in, but I'm just going to go to number 3. This is going to be recorded, so you can check it out later, okay? Number 3, find the quadratic function of the vertex with a vertex of this that passes it through 12. So there's another type of formula. The previous one we did was the standard form. This is going to be called the vertex form. Y equals a x minus h squared plus k, where h comma k is your vertex. A works the same way as the other A, which it tells you if it's upside down, upside right, if it's a vertical stretch or shrink. And then X and Y are just being generic X or Y points. Since they told me the vertex is 4 comma negative 8, I could plug in for H negative or 4, I guess in this case. And for K, I could plug in 8, a negative 8 technically. It'll be minus A. I'm just plugging it in like that. They give me a generic point of 212. So I could plug that into my XYs. So I could plug in 12 for Y. I don't know what A is, and that's okay. And I could plug in my X, which is just 2. From there, I'm going to do all this math simply to find what the A value is. So I'm going to do 12 equals. Just so I'm plugging it in. There's nothing matters. Yeah. 2 minus 4 is negative 2. Negative 2 squared is positive 4. So 4A minus 8. Plus 8 on both sides. 20 equals 4A. Divided by 4 on both sides. A equals 5. So A equals 5, but that is not your final answer. Your final answer is what's the formula. So the formula should look like this. And this is how your multiple choice answer will look like. Y equals 5, x minus 4 squared minus 8. So this is how it would look. The vertex form generically is this thing right here. Yes. Yeah, it could be a multiple choice. Yeah. It could be. Yeah. I'm not making any promises one way or the other. That would be called standard form. If you want to look it up later. Yeah. Any other questions on the vertex form right now? Okay, number 4, end behavior. Now, end behavior, if you remember, matters when you go towards affinity. So when your numbers get really, 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 really big. Because your numbers get really, 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 really big, small numbers don't matter. And nothing makes something small by not having a big enough exponent. So I always look at what has the biggest exponent, okay? If the biggest exponent is even versus odd, if the biggest exponent is even and the number in front of it is positive, it looks like a parabola like this, which means as I go towards positive affinity, it is going towards positive affinity. And just a reminder what this means, actually, let me be clear. As I go to positive affinity xy's, so I'm going to, in this case, the right, my arrow's going up, so my y value is going positive. As I go to the left, aka negative affinity to the x value, my arrow's pointing up, so that will be my y values are going to the positive affinity. If it was positive but an odd power, it would look like x cubed, which looks like this. It also kind of looks like a tangent, yeah. So, in this case, as I go to the right, my arrow's going up, so positive, positive. As I go to the left, my arrow's pointing down, so negative, negative. The top one is right. Is going right, yes, and then this is going left.
Those are both at the number.
Yes. If the number in front is negative, it will look like an upside down parabola. For the power. So this is for the power. This would be for the coefficient. If the negative number in front, but even power, would be an upside down parabola-ish, looking-ish. So because of that, as I go right, so positive infinity, I'm going down, so negative infinity, so positive, negative. As I'm going left, my arrow's pointing down. If it looks like odd but negative, it would look this but upside down. So as I go to the right, it's going down, so positive, negative. As I go to the left, it's going up, so negative, positive. That's just your, I guess, key to telling what to do. So in this case, it's positive 4 and to the power 6. So it's even and positive. So it should match whatever even and positive is. As I go to the right positive, it's positive. As I go to the left, it's also positive. Yes. Or it's a set of answers, yes. I might, I'll look at the multiple choice. Either it will say in more words. It might be as I go to the right, it's positively, or it might just say it like this. So I might just write it as more words to be less confusing, honestly. All right, this one. The biggest exponent is 7, which is odd, and negative 3. So it's a negative odd one. So negative odd one should match the bottom right here. So it's going to be as I go positive, it's going down. So that's a negative. And as I go left, negative is going up, positive. In this one, you need the biggest exponent, which is this one actually. So it's negative and it's even. So it's a negative even. So I follow negative even. As I go positive, it's negative. As I go negative, it's also negative. You can think of it like that. I like to think of it like these little shapes, so I don't have to remember all the infinities. I'll get confused on the infinities aspect of it. You can also, you can also, absolutely. Let's take B for example, which is negative. What is that? To the 7. I could take my calculator, go y equals negative 3x to the power of 7. What is it? Minus 100. Graph. Now it's going to be awkward because it does like. So you're going to do zoom and then which option? Zoom fit, which is option 0. So you can see, oh, as I go to the left, it's positive. As I go to the right, it's negative. So you could use your calculator. And that's why I didn't allow the calculator on the test when the first time we took it. All right. All right, cool. Let's keep going. All right, give a polynomial that has these zeros. If I know it has these roots, these zeros, these solutions, these x-intercepts, I know before I had this must have been x. Before I had this might have been x plus 1. Has to be. And this had to be x minus 3 equals 0. Well, no, then the multiple choice option, it will be foiled out. So we're going to foil this out. So I'm going to foil this out. Because, let me just make sure I explain for the video. In this case, if I were to solve this, I would get these as the answers. So I know if I got those as the answers, this is must have how it looked like before. Technically, I could multiply everything by 2. Technically, I could add an extra exponent, but this is a correct answer. This would be the most simple. Don't stick to your memories. Let's move forward, man. So equals 0. Then we're going to do FOIL. X cubed minus 3x squared plus x squared minus 3x. You combine like terms, but it's just this is like terms. So x cubed minus 2x squared minus 3x equals 0. Or actually, I guess in the answer, it would just look like this part, not the equal 0 aspect of it. All right, number 6. Given that 2 is a root for this equation, find the other 2 roots. So this is one of the favorites, synthetic division. Anyone remember that? So I'm going to put 2 here. And then we're going to put the coefficients. So the number here in front is 1. The number here is 5. I'll show you how to do it in the calculator app. 5. This is going to be a negative 2. This is going to be a negative 24. Okay? Now, the thing with the calculator, it will not give you imaginary roots. So you have to keep that in mind. So it could trick you.
That's fine.
It's okay. So I always bring it down, 1. And then I'm going to multiply 1 with the number on the outside. So 1 times 2 is 2. Then I'm going to add down. So 5 plus 2, 7. Multiply, it's going to be 14. Add is just 12. And then multiply 24, add 0. Which makes sense since I told you 2 is a root. We knew that it should become 0 at the end. So now it started as x to the third. Now I can see this as x squared, x, and no x. Because the zeros canceled out, right? So let me rewrite that over here. X squared plus 7x plus 12. When I look at this, I could continue synthetic division. It was x third to the beginning, so it becomes x squared now. Yes, or you could think of it like this. This is, you just remove this. So this is x negative 1. This will always be x0 and then count up. You could think of it like that too. All right. Anyway, so this one is what's left over. Instead of doing synthetic division, I could just factor this. So I'm going to take this, which is 12, and I'm going to factor it. So 12. Things that multiply to 12 that add to 7. Good. 3 and 4, 4 and 3. X plus 3, x plus 4 equals 0. So my answer should be good, negative 3 and negative 4. Why is it negative 2? Negative 2 here. Let me circle it. Negative 2 here. It was negative 2 with this x. So I had to follow that along. Yeah. So now the question is, how can I use the calculator to make my life easier? So I'm going to go to y equals again. Clear this out. And I'm going to plug in the equation, which is x to the third power plus 5x squared minus 2x minus 24. So if I click graph, well, I got to zoom a little bit. Let me zoom fit again. Let's see how it looks. If I graph, you get this kind of curve, right? Now, if I click second table, what could help me out is I could see where zeros exist in the y values. A couple of caveats. How this thing is set up, you're not going to get the decimal ones. Also, your calculator cannot calculate imaginary things. So it will miss out on that too. You could get a decimal.
How does that help you?
So the answers was negative 3 and negative 4, right? I could see where y equals 0. It's negative 3 and negative 4 and 2. And secondarily, it does not tell you if it's a double root from this situation. So it's limited, but it's super useful. Not really, you know. They told me is too, yeah. 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 All right, let's continue. Talking about imaginaries. Imaginaries show up. Luckily for us, yeah, because that would be your x-intercept. You're always looking for x-intercept. Well, not even. It's just, you don't even put it in the calculator. It's just combining variables. So 7 plus negative 3, 4. 5i minus 6i minus I. They can't calculate imaginary numbers. It's just straight up combining fractions. There are combining variables. There's one thing we have to remember about I, which I'll talk about when it shows up. Yeah, you're remembering. All right. So yeah, you're just combining variables as if it was x, nothing changes. But let's say we do 8i times 3 and 8i times 5i. That's going to be 24i plus 40i I squared. I, by definition, is the square root of negative 1. Since that's true, I squared would be the square root of negative 1 squared. But wait, square root and squared, that would just be negative 1. So any I squares become negative 1. So I can rewrite it as 24I minus 40. And technically, you always put the real part in first. So it'll be 40 plus 24I. On the multiple choice, this is how it looks like. I would not give you a fake answer like this because it's still technically correct. Don't worry about that. But it will look like negative 40 plus 24I. I'm not swapping it to trick you. It's just the proper way is to put real parts first, the real component first. Yeah.
Yep.
Same thing. When you FOIL, 12 minus 30I plus 6I minus 15I squared.
There's just more eyes.
Yeah. I squared becomes negative 1, so this is going to become a positive 15. So 12 plus 15 is 27. Negative 30I plus 6I is minus 24I. All right. Remember, I is the square root of negative 1. I just call it math grammar. It's grammatically not correct to have square roots on the bottom. So to fix that, so what it's going to do, it's not the I.
Yeah, it is right on over the 0.5, the I one.
I'll look into that later. Then actually, I
I think
didn't.
there is. I think
It gave me that.
That'd be cool. Anyway, I'm going to multiply the top and bottom by I. The reason is I don't want i's on the denominator. So I'm going to multiply top and bottom. So 2I over 3I squared. And the reason I can do that is because I squared makes this negative 1. So then I can rewrite this as negative 2I over 3.
negative.
Yeah. Well, the negative, you can put it anywhere, top, bottom, front.
Can you
I don't think you can. I didn't think you can. Yeah, but that doesn't help you in this situation.
Over 3 is 0.6.
I guess.
Look, you just put it when you see all four answers, it just simplifies.
No, it doesn't give it to you. It gives you 64.
It gave me.
I mean, that actually works.
yeah,
Yeah.
look, gave me all the
That's
answers.
what you got.
I don't know.
All right, cool.
Come on.
So you guys teach it amongst each other because I didn't know that. All right, cool. The calculator is actually better than even I realized. So anyway, that's for you guys to figure out. I'll continue doing my root video. Again, I need to fix this on the bottom. So it's going to be 2 minus 3I because I need to use it's not composite. I forgot what it's called. Conjugate? No, it's not reciprocal. It's not the, maybe it's the conjugate. Anyway, I'm going to distribute the 10. So 20 minus 30I. On the bottom, I'm going to FOIL. So it's going to be 4 minus 6I plus 6I minus 9I squared. This is negative 1. So that's, it most of the time works like an x. Just when you square it, it becomes a negative 1. These cancel out because they're the same. This becomes negative 1. So it's plus 9. So 20 minus 30I. Negative 1. I squared is negative 1. I normally is the square root of negative 1. It's imaginary because you could kind of understand the square root of negative 1 should be something, but you can't technically get the square root of negative. It won't look like that in the multiple choice, so just know that. Yeah. All right, find all the roots for this. Now, like I said, there's some fractional roots, but here, what I'm going to do, if I were to doing this on the test, I'll take it, type this in, and who knows, maybe there's a button in the calculator that says, give me all the roots, but you figure that out on yourself.
Just put a calculator.
I'm going to do this on the calculator to show you the easier way. I think you could because you remember. Do you guys remember the Q over P? Then you had all those options. Then you had to guess and check which one was right. And if you get it right, you got to keep going. Instead, let's minimize the amount of guessing. What do you mean? I mean, that could be open ended though. That's fine.
I think the 25% chance that
You could minimize the chance though. You can minimize the chance though. You don't have to.
there's 100% we don't have a calculator.
I think a lot of it could be on the calculator. Yeah, apparently more than I realized. So who knows? Maybe I'm wrong. You know. Anyway, I'm gonna graph. Gets me this weird curve, but that doesn't really matter because what I really want is second table, and I want to see where there's zeros. So I could see -2 is the answer, 1's the answer, 2's the answer. There's zeros, right? So -2, 1, 2. So I could write that down actually. -2, 1, and 2. Now, does that count for all my answers? I know I should have 4 answers. So no, it doesn't. So what I could do is use some synthetic division. Like I could put 1. No, not necessarily. That's imaginaries. If you have the imaginary of the positive, you will also have the imaginary. You still have to do the division, but you don't have to guess and check. You know these work. Yes. When I click second graph, I get zeros on -2, 1, and 2. So I know at minimum there's one root that matches that. It might be a double root, but in one root matches that. I think in this one, if I remember when I graded this, I made it where one of them was a half or negative half. So I'm just going to keep going until I got that. So -1, -9, 4, 4. Bring down to 2. 2 times 1 is 2. 2 plus -1 is 1. You didn't have a calculator on the test. Yes. 1 times 1 is 1. -8. -8. 4 times negative, or 4 plus -8 is -4. -4, 0. Which matches what we expected. Is it? I know there has to be 4 though. Now I don't know if any of these are doubled possibly or something like that. No, if I remember when I made this whatever I made this months ago, one of the answers was a half, and I did that on purpose. Yes. If you started from the thing, you do Q over P, which is all the factors of 4 over all the factors of 2. You end up with something basic. So let's just keep going. So 2 times 2 is 4. 4 plus 1 is 5. 5 times 2 is 10. 10 plus -8 is 2. 4. Not that well. Let's keep going, right? And then I'm going to plug in this one, which is -2, right? 2, -4, 1, -2, 0. So what is this? Remember, this is x to the -1 technically. So this is x to the 0, x to the 1. So now I just have 2x plus 1 equals 0. Wait a second. I can easily figure that out. What's my final answer? Good. My final answer is -1 over 2. So my answers is -2, 1, 2, negative a half. If you don't get, like, if I got 4 answers, I would not need to do it. You know why? I know I will have 4 answers because it's to the 4th power, the biggest thing. Okay? That's why. If it was to the 5th power, I know I need to keep going until I find 5 answers. Again, the calculator will give you one of the roots. You're not sure if it's doubled. Secondarily, you're not sure if you have a decimal. So that's why we have to still look it up. All right. Whoa, we're still on this test, man. Jeez. Okay. What do we got? 5 more minutes? All right. Let's do this quick. All right, this one. Now, you could use the calculator again to check your stuff. Y intercept. That's when you make the top. If I was going to call this P of X over Q of X. Yes. Yeah. Like I'll post this in the 5 minutes after we leave. Because I'm doing it through a program on the computer instead of like Google Chrome or whatever. All right, y-intercept. When you have the y-intercept, that means x equals 0. So I would plug in 0 into this. It would be 0, 0 because the top will be 0.
What's the P over Q thing?
I'm going to tell you in a second. X-intercepts, that's when you hit the x-axis. So you get x-intercepts when the top equals 0. So when p of x equals 0. So in this case, I'm going to say 0 equals x because that's the top. But in this case, it's pretty obvious. That is going to be, again, 0, comma 0. There's nothing special about it. Vertical asymptotes. That's when the bottom equals 0. So q of x equals 0. If you were using a calculator on the vertical asymptotes, it would show undefined. Actually, I'll plug this in afterwards to show you. So I will make the bottom equal 0. So x squared minus 4 equals 0. A little factoring and cleaning up. Hopefully you can see x will equal plus or minus 2. So the vertical, it says undefined. What does it say? Error. So I'll say error then. X equals 2 and x equals negative 2. And then horizontal slant asymptotes. You could. I'm just showing you this looks like this. If I put it as a multiple choice answer, it would look like this: x equals 2 and x equals negative 2. And then horizontal or slant asymptotes, it's based off the powers. If you remember, if p is bigger than q, then it would be no horizontal asymptote. If it was p equal to q, then it would be the ratio of the biggest exponents. So in this case, it would be like AB. And then if it is p smaller than q, aka the bottom has a bigger power, if the bottom has a bigger power, it's automatically equal to 0. Y equals 0.
If p equals q and what?
Then you take the coefficients of the front numbers, which I think the next question has. This one, so be y equals 0, yes. Top degree. These are degrees when I'm talking about p's and q's. So I have a horizontal asymptote at 0. I have a vertical asymptote at 0. Oh, no, I don't have a vertical asymptote at 0. I have a vertical asymptote at 2 and negative 2. Question is, how do I graph this? Well, luckily for you, you can either A, plug in numbers, or B, you have a calculator, bro. So just go to your calculator. Yes, x over, and just make sure you put it in parentheses or it will not work. You know the calculator more than me, Monty, at this point. I don't know. I trust you, man. Go to Monty if you need calculator advice because I didn't even realize you could do these things. Okay, that's a horrible look, but we'll do zoom fit or zoom 0. Looks a lot better. Hey, looks like that. Well, let me just draw that. Yeah, kind of like this. Goes around, then it goes here. This is one of those cases you could actually pass the asymptote with a x-intercept. Look, see, looks like that. That's not the worst thing. If you're getting some memories back while you're learning, yeah, it's 60. I thought I said 60. I think it is 60. 60, and then open ended. I think I put 20, but I'm going to take your best 15. You get 2 hours, and if you have extra time, you get 3 hours. But no one. If you run out of time, you were cooked already. So like, don't sweat it. Like, you're not gonna run out of time naturally. Okay. It's gonna end in a minute. I don't want to stop. You could leave. You could